Okay, in this demonstration, I'm going to show what would happen if the Earth were to magically stop spinning. So say this watermelon is the Earth, and this glue stick taped on is civilization. So if we were to keep the Earth spinning, but then magically stop it, right? The glue stick just flies off, okay? And the path that it flies off on is actually tangential to the Earth. So what this shows is that the Earth is moving at a constant velocity, which is actually pretty fast, except we just can't sense it, and that's because of a concept known as relative motion. So relative motion essentially is how we perceive the motion of objects away from us. So if we were to imagine that the Earth is object A moving in this direction, and say like the moon is object B moving in this direction, and we have object C in the middle of the two, just like a random satellite or something, then we could actually dictate the velocity of object A with relation to object B with reference to object C in the middle by setting up the equation velocity of A to C plus velocity of C to B. So the reason we actually can't feel the spin of the Earth is because we are part of the Earth. So there's no other like separate reference frame that we could create to isolate the velocity of the Earth, since we are one with Earth. Theoretically, we could attempt to isolate it, but it would involve us having to be on a highly large object, and it would also involve a lot of complex calculations, and due to the sheer size of the Earth, it would be relatively impossible for humans to isolate the velocity of the Earth right now with our current technology. And then another phenomenon that has been occurring with the Earth and the spin in general is the Earth's spin is actually slowing down. So one reason this is happening is because there's a centripetal force between the Earth and the moon. So the Earth is pulling on the moon with its own gravity, but the moon is also pulling back on the Earth. And this illustrates Newton's third law, which is for every force there's an equal, for every action there's an equal and opposite reaction. So essentially, Fe to m, the force that the Earth has on the moon, is also equivalent to the force that the moon has on the Earth in the opposite direction. So when the moon applies its own force back on the Earth, what that creates on the Earth is actually tidal waves. Like, that is why waves occur, because of the moon's pull. So this is actually also creating a phenomenon known as tidal friction, and gradually, as the moon continues to pull on the Earth, our Earth is actually slowing down in speed. So, and this is resulting in like us having to like reset our clocks, or the government resetting the national clocks by approximately like 1 second. So these two examples with the Earth just illustrate two basic concepts of relative motion and Newton's third law.